In this section, we're going to be talking about liquid properties, and we're going to focus on two of them, surface tension and viscosity. First, surface tension is basically what's considered to be the skin of a liquid. And it's the property that allows water bugs to walk on water. So if you look at this, this is a water bug here. And one of the reasons that they're called water bugs is their feet are, or their legs, are adapted in such a way that instead of just a point hitting the water, there's a flat section that sits on top of the water. But the skin that we're talking about is that you can see here where the water bug makes contact, that there's a divot in the water here and here and here. Okay, there's a smaller one here, it's hard to see. And that's the reason that happens is something called surface tension. Here's the same type thing. You can actually do this yourself with practice. You can put a paper clip on a glass of water. If you want to get a parlor trick to fool your friends, you basically would take two glasses, one having pure water in it, and you show your friends that you can put the paper clip to get on to float on the water. In a second glass that looks identical, what you did before you came out was you added a drop of dishwashing liquid like Dawn or Joy or whatever one you want to use. And you mix that in, and if it's only one drop, it shouldn't change the color of the water. But what it does do is it makes this impossible. So no matter how much your friends try, they cannot get the pen or the paper clip to stay on top like this. It will always fall through. Because by adding something to that water, I've changed the surface tension of that water. So here's a diagram from the textbook that shows surface tension. Inside the middle of the water container, this water molecule is attracted to all of these other water molecules, including one coming out of the screen and going into the screen. So it's 360 degrees water molecules, and they're all attracted to each other, which is what makes it a liquid versus a gas where there's no real interaction between them. But when I get to the surface, this attraction still exists from side to side and down below, but there are no attractions up here. So my net attraction, these two cancel each other, my net attraction is going down. And so that gives kind of because there's an attraction down, that gives it a rougher, it's harder to pierce this level of the surface. Now, you can actually tell something about surface tension by putting them in a small tube. If I take a tube and I add water to it, then I create something called a meniscus, in which the water makes like a U inside the tube. And that's because the water has a greater attraction to the glass or plastic. This happens less in plastic, but into the glass has a greater attraction to that, and so it tries to climb the glass surface than it does to each other. If I choose a different substance or different liquid that has a higher surface tension, the opposite will actually happen. And so it actually will look like this. And this is something like mercury. And it doesn't have to be in a glass tube. If I put it on a flat surface, then my water is going to spread out very thinly over a large area. Whereas if I do the same thing for the mercury, it actually forms a bead on top of the surface. And this, other than the fact that mercury is kind of dangerous to play with, this is kind of fun. If you knock it, then it will just roll away. And so that's because mercury has a much higher surface tension. So here the mercury likes itself more than it likes the container or the surface that it's in contact with. Okay. The second one is viscosity. Viscosity is the resistance of a liquid to flow. Okay. It changes with temperature. I've put the link here to the video because I'm not sure if you'll be able to hear the sound, but I'm going to play it anyway.
Hey everyone, it's Danielle from Cool Science Experiments headquarters. For the experiment today, we're going to take some marbles and we're going to drop them in different liquids. And we're going to see how they behave differently based on the liquids we drop them into. Are you ready? Let's get started. To begin the experiment, we have started with 4 jars and we have filled each of them with a different type of liquid. In the first jar, we put water. In the second jar, we put corn syrup. In the third jar, we put oil. And in the fourth jar, we put honey. Now,
she's going to drop marbles or balls inside of each one of these. Which one of these four, the water, the cornstarch, or corn syrup, oil, or honey, which one of these four do you think is going to be the most viscous?
We're going to take a marble and we're going to drop one marble into each of the jars. And we're going to see if the marble behaves differently based on the liquid that it's dropped into. First, we'll drop a marble into the water. Next, we'll drop a marble into the corn syrup. Now, we'll drop a marble into the oil. And lastly, we'll drop a marble into the honey.
You can just now see the ball is right about here. It's kind of difficult to see, but it is still falling. So based on that observation, which one is the most viscous? Water, corn syrup, oil, or honey? It's the honey, followed closely behind by the corn syrup. Both water and oil are so non-viscous that it basically, you can't tell the difference between those two. Okay? And in the next section, we're going to be describing what causes viscosity and surface tension to be different among different types of compounds or molecules.